Finally, this is going to be the last Calculus 1 video, and this video is going to be about average function value. So you're going to be using integrals to calculate the average y value, or value of a function, right? So what do I mean by this? Well, let's say if you have some curve, you'll have some average value maybe somewhere along this dotted line, right? If you were to add up every single y value along this function, and then divide it by the amount of y values that you had, then you would have your average value, right? Add everything up in a set, and then divide it by the amount in that set. And then you get the average value. So you can actually calculate the average value of a function, or the average y value, by finding the integral, and then dividing it by the width of the interval you calculated the integral along. So if you found that this area under the curve was 10, so to say, 10 units squared, and the width of this interval was 5, right? You would divide area over width, which is b minus a in this case. So b minus a is, well, the end value and the start value are b and a, and the distance between a and b will be the width of your interval. So how do you calculate this area? Well, this area is simply an integral. So if we were to exchange area, which is 1, and we set up the integral here, a and b, for a function, this is the general formula for the average value. You'll get the average, let's get right, y average, the average y value of your function. So using this formula, you can solve for many things. Like the hardest part is just solving for integrals, but hopefully once you've reached this part of Calculus 1, you know how to solve for definite integrals by this point. If you don't, oh Lord. Yeah, you might be cooked if you don't. But yeah, it's okay to be cooked. It's okay to be cooked. You can watch videos on that. I have a lot of videos on that if you check out my Calculus 1 playlist. But once you find the integral, just divide it by the width of your interval by subtracting a from b and putting that into the denominator of a fraction. So let's go ahead and do some problems and apply this formula here. Let's go ahead and calculate this. So first thing we want to do, we can find the area under the curve within the interval, of course. So the area under the curve in this case is the integral from 0 to 4 for our function 2x plus 1 dx, of course. And if you want to find the integral of this, well, the indefinite integral of the antiderivative is just x squared plus x, and the bounds are from 0 to 4. So we plug in 4, we get 16. 16 plus 4, plug in 0, you get nothing. So you get an area of 20. All right, so remember, although we solve for the integral part of this formula, you need to divide 20, or multiply 20, by 1 over the length of the interval. So if b is the upper bound and a is the lower bound, we have 4 minus 0 in this case for b minus a. Therefore, the width of our interval is just 4. Now that we have 4, we can simply divide the area, right? Area divided by b minus a. In this case, we have 20 over 4, so the average y value is 5. So this whole formula kind of looks sloppy. Maybe I should have said this at the beginning of the video, but you really don't have to memorize this entire thing. Literally, if you just remember area divided by width, then you can kind of already, take out some conclusions off of area divided by w, right? Area can be calculated with the integral, with your function, and width can be calculated by just subtracting b minus a. So memorization, it's really, you don't have to memorize the entire thing. You can just memorize a over w and then take that as you will. But let's go ahead and calculate the integral for this first. So the bounds are 0 and pi. And the function is sine of x. Therefore, our antiderivative is cosine of x from 0 to pi. So if we plug in pi for cosine minus negative cosine of 0, we get 1 plus 1, which is equal to 2. So the area or the net area at least, between the curve and the x-axis is 2. Keep in mind, average y value can be negative as well, so that's why I'm saying net area. But let's go ahead and solve for the width of the interval. Well, the width of the interval is simply b minus a, which is upper bound minus lower bound, pi minus 0. Pi minus 0 is just pi. So 2 over pi is equal to our average y value. All right, let's first go ahead and find the area. So the area of our function is the integral. Our bounds are 1 and e to the power of 4, and our function is 1 over x dx. The antiderivative of 1 over x is the natural logarithm identity. Technically, this should be absolute value, but you know, I don't think that matters too much since we were dealing with positive numbers anyways. But natural logarithm of e to the power of 4 minus natural logarithm of 1. And this simply is 4 minus natural logarithm of 1, which is just 0. So our area under the curve, or area between the curve and the x-axis, is 4. Okay, now that we have the area, of course we divide it by the width. The width is simply e to the 4th minus 1, which is equal to, well, e to the 4th minus 1, right? This is b minus a. There's really no other way to simplify this, so you can keep it like this. And we divide area, which is 4, by the width of our interval, which is e to the 4th minus 1. So really all you need to know, I mean, like, you didn't really need to, I feel like most people don't need to do practice problems for this. All they needed was some understanding of what in the world is average value, right? What in the world is that? You guys probably clicked off of it. Like, most of you probably clicked off in the first, like, 30 seconds because I already explained it then. And I also showed the formula. But it's really area divided by width. That is all. Okay? So, if you have any questions, put down in the comments section. And if you found this video helpful, consider subscribing and liking the video. And since this is my last Calc 1 video, I really don't know if I'm missing out on some things that you guys are learning in your Calculus 1 class. So, you know, if you have any suggestions for what to make, I'd be happy to make a video on it. Maybe I'll just watch like a YouTube video or something and then teach it in the way that I teach it, or what else would I do? I would read some textbook. I mean, like, I'm reading some textbooks right now, so I can make more videos for you guys. I'm also going to take more classes, more engineering classes next semester, so I can't wait to take make videos on electromagnetism. What else? Electromagnetism, discrete math, and differential equations. Yeah, and also linear algebra. So that's it for the video. Thanks for watching.